Hi guys, good morning.
Good
Everyone
morning,
ready?
ma'am.
Yeah. Okay. So, so we have been seeing chemical kinetics, right? So I think last class we did that tabular column kind of problems, right? To finding out the order, the rate law, rate constant, the table of data is given to you. Right? So we saw how to calculate the rate law, how to calculate rate constant, and then sometimes rate, all that, right? Okay, so we'll move on, right? We'll move on to specific order reactions, right? So in our syllabus, we have zeroth order reactions and first order reactions. Okay, so it's very simple. It's just that you need to know the formula and then you need to know the problems on that, right? So we'll move on with it. Okay, right. So first, we start with your zeroth order reactions, right? Okay. So what we know how the rate law is going to look. So I know the rate law is going to look R is equal to K R power 0. So I'll be able to write this as K into R is equal to K, right? So and I know how the graph will look for this zeroth order reaction. Say if I plot a graph between rate and the concentration of the reactant, right? So how the graph will be? I know it is going to be parallel to the x-axis. Exactly, isn't it? So the thing is why, because I can see that the rate is equal to the rate constant. That is, it is independent of the concentration of the reactant, right? So you'll see that I'm going to get a graph like this, right? Okay, so we'll do a small derivation, right, for us to get a good mathematical relationship. Okay, fine. Hope you're all okay with. Did they start integration for you, guys, in mathematics?
Yes, sir.
Okay, cool. So that's what I wanted to know. Fine. So we'll go on with it. Right. Now, how will I write? How will I be able to write my rate of the reaction? Right. I'll be able to write the rate of the reaction as rate of change of concentration of the reactants. Reactants is concentration. It isn't it? It is this R. I'll be able to write it as rate of change of concentration of the reactant. Right. So I'll be able to write this R as minus. One second. I'll take a better marker. So I will have minus dr divided by dt. I'll be able to write this r like this, right? So obviously what I define as zeroth order reaction, that is equal to k, right? So now what I do is I bring this dt this side. So I will have, or I'll bring the minus also this side. So I will, or okay, no problem. Dr is equal to minus k dt, right? So now I'll integrate on both sides. So dr is equal to minus k dt. Now I'll integrate on both sides, but the limits are important. From where to where is the question now, right? So obviously in case of the concentration, it is actually going to be from the initial concentration to the final concentration. R naught represents initial concentration, R represents final concentration. And here it's obviously going to be from time t is equal to 0 to time some t is equal to t. Right? So these are the limits now. Done. Okay, so that's it. I have to do the integration part. So I know integration of dx is what? Integral dx?
X.
X, right? So I have the integral of dr, so it is going to be r, right? So here I'm going to have concentration of r from the initial concentration to the final concentration. Again, I have k is a constant, minus is a constant, so I'll be able to take it out, right? So I'll be able to write it as minus k. Again, dt is there. Integral of dt will become t, right? And 0 to t. If I try to substitute the limits, it is again going to be t only, right? So I'll just write it as minus kt. No problem. Okay. So now I'll just substitute the limits. That's it. We got the equation, right? So I'm going to have now if I substitute this, it will be upper limit minus lower limit, right? But since I have a negative sign here, right, I just take this negative sign. If I take it this side, it is generally going to be upper limit minus lower limit. But since there is a negative sign, I'll write it as lower limit minus upper limit. No problem, right? Again, I repeat, generally it will be upper limit minus lower limit, right? But I have a negative sign here, so I'll write it as lower limit minus upper limit. That's it, right? So I will have r naught minus R is equal to KT. That's it. This is the equation which you have to remember for your zeroth order reaction. R naught minus R is equal to KT, or R naught by R naught minus R divided by K is equal to T, whatever it is, right? So this equation which you have to remember, R naught minus R is equal to KT, is the equation for zeroth order reactions. Okay, now I'll be able to get some graphs out here, right? So okay, so how can I get the graph is, say if I plot a graph between the final concentration and at time t, can you just tell me how the graph will look? Looking at this equation, right? Can you tell me how this graph will look? I'm plotting a graph between the concentration of the reactant and time. I'm not talking about the rate and time. Rate and time, I know how the graph looks, parallel to the x-axis, right?
Sir, it will be a
will
straight line and
Hmm.
r naught distance from the x-axis.
R naught is the
R naught distance, it will be the intercept, sir.
correct, exactly. That's the word, intercept. Okay, what will be the slope?
K.
Good, very good, right? So now if you look at here, right, I'll actually be able to rewrite this equation a little bit like this, because I have R and T. So I'll be able to write this as R is equal to R naught minus minus or plus. This becomes minus K. This is what you'll have, right? Is it correct? So if I bring this here, correct, everything is correct. Okay, cool. So if I write the equation, right, what you're seeing here is basically, you're seeing that it is this.
Negative
Okay,
slope,
if I write negative slope, correct, right? So if I write this as y, and this t is my x, and y-axis I have the final concentration, t I have in the x-axis. So obviously this would be c minus mx. This would have been the equation. Y is equal to mx plus c, or say y is equal to c minus mx, whatever it is, right? Okay, so what do you see? You are going to have a straight line with a negative slope, because I see that the slope is negative, right? And I'm going to have an intercept. So you'll see a graph like this. So obviously this point was my initial concentration, right? Obviously I know what is going to happen during the reaction. The concentration of reactant keeps on decreases. The same thing is happening here. As time increases, the concentration of the reactant keeps on decreasing, isn't it? So that was the initial concentration, and obviously slope of this line would have been minus k, right? Because I can see that it's actually minus k. Okay, fine. Now this is one equation which you have to remember. And again, derivation, sometimes it might be asked, but very simple only, right? You just have to substitute R in terms of dr by dt and do the integration and substitute the limits. That's it. You will be getting this equation, right? And I have one more equation for your t half, right? So that also will do. Right? So now for t half equation, I'll just derive it from this equation itself. R naught minus R is equal to KT. I'll be able to do this here. So if I substitute in this equation t as t half, right? In this equation, instead of t, if I put t half, right? What do you think will happen to this R?
It will double, sir.
Double. What do you mean by T half? I told you, right? T half is the time taken for the reaction for 50% completion, or the concentration of the reaction to become half of it, right? So what will happen to R now?
Half.
What?
Half.
I get so sleepy. Open up, please. I'm not able to hear.
Half, sir.
Yeah. What will happen to R? I'm asking.
Half.
Half of what?
Sir, can't get the question, sir.
What I'm telling is, if I put instead of this t, I'm just putting not some t, right? Some random t is what is here, right? So instead of this t, if I put t half life period, what will happen to r? I'm asking. If I tell you the answer, you'll say, ah, correct, sir. Yes. It will become R naught by 2. R naught is the initial concentration, correct? So in the half life period, what would have become? The final concentration would have been half of the initial concentration, correct? Right? So if I put T in place of T, if I put T half, R would have become R naught by 2. That's what it would have become. Final concentration would have been half of the initial concentration, right? So I'll just rewrite this equation like this. I have R naught minus R naught by 2, because this is the final concentration now after the first half-life period, which will be equal to K into T half. That's it. This is just rewriting this equation here. Everybody understood why it became R naught by 2? At the half-life period, the concentration will become half of the initial concentration, right? Okay, so R naught minus R naught by 2 will become R naught by 2 is equal to K into T half, right? Or I can write T half for the zeroth order reaction is going to be R naught by 2K. This is another equation which you have to, right? This is another equation which you have to remember. R T half is equal to R naught by 2. Done? So again, I can have some graphical representations here, right? I can have two graphs. So one between T half and K, right? So one between, say, T half and K. Sorry, I would say 1 by K. 1 by, or it's better that, oh, no problem, 1 by K, if I put, right? So how do you think the graph is going to be, guys? T half and 1 by K. Is it that tough? T half and 1 by K, how do you think the graph is going to be?
Inverse.
Straight line.
Inverse?
Inversely proportional.
Okay, T half is inversely proportional to K. But T half is what to 1 by K?
Sir, straight line passing through
Proportional.
origin. Sir.
Correct. So it's the answer is right. It's actually straight line passing through the origin. Very good. Yes. So you can rewrite this equation as T half is equal to R naught by 2 into 1 by K. So what's like this? It's equal to Y is equal to mx. In x only I have 1 by K. Correct. So obviously it is going to be a straight line passing through x-axis, and obviously the slope of this line is going to be what? R naught by 2.
R not by 2.
Correct, right? So same graph, if instead of 1 by K, if I put R naught, it's going to be same thing, right? Again, Y is equal to mx,
Same
just
thing,
that,
sir.
it's just that the slope is going to vary, right? In this case, this is the straight line. So in this case, the slope is going to be actually 1 by 2K. You can see here. So I can rewrite this like this: R naught into 1 by 2K. So this is my Y, this is my M, and this is my X. So slope here is going to be 1 by 2K, right? See, the graph questions can come anywhere. They can ask you in 1 mark. They can ask you, say, in one part of the 2 mark. Something can happen. So graphs are little important in this chapter alone, chemical kinetics. That's why I'm stressing so much on the graphs. And 99% will be straight line graph. So if you just know Y is equal to mx plus c and how to rewrite the equation accordingly, easily you'll get the graph, right? Okay. So two equations you have to remember for zeroth order. One is R naught minus R is equal to KT, and another for the T half is equal to R naught by 2K. Those two equations you have to remember. Okay. So we'll do some problems on this. But problems point of view, first order is little more important than zeroth order, but still you have to do the problems on this. Okay, a question. A certain zeroth order reaction, has K equal to a certain zeroth order reaction has K is equal to 0.025 mole per liter per second. So K is equal to 0.025. Yeah, 0.025 mole per liter per second. Right. So they're asking, what will be the concentration of the reactant? What will be the concentration of the reactant after 15 seconds? What will be the concentration of the reactant after 15 seconds? If the initial concentration is 0.5 m. If the initial concentration is 0.5 m. So repeat the question. A certain zeroth order reaction has K is equal to 0.025 mole per liter per second. What will be the concentration of the reactant after 15 seconds if the initial concentration is 0.5 m? So I think it's direct formula substitution. You don't have to do much. So just substitute R0 minus R is equal to KT. Everything is given. They're asking you what is the final concentration after 15 seconds.
0.125, sir.
Yeah, I think it should be correct, right? So I have R0 minus R is equal to KT. So R0 is given 0.5, R I have to find, K is 0.025, and T is 15 seconds, right? So yeah, I think R value should be 0.125 m. Yes, it's correct, right? So just formula substitution, right? Okay, fine. We'll go to the next question. Just substitute. You'll get the answer. I'll give you 1 minute. I'll go to the next question. Right? Okay, next question. For a zeroth order reaction, A giving B, for a zeroth order reaction, A giving B, initial concentration of A, or I can write it as A naught. A naught is equal to 0.01 m. A naught is equal to 0.01 m. And the concentration of A after 10 minutes and the concentration of A after 10 minutes is 0.008 m. Right? And the concentration of A after 10 minutes is 0.008 m. Right? So they're asking, find the half-life. Find the half-life. Half-life is T half. Right? So they have given the reaction, they have given the initial concentration, final concentration, and the time period. Right? Find the T half. So in this case, you have to use both the equations, is it not? What is not known? So basically, I know T half equation is R naught by 2K. That's it's simple equation, but I need to know K for that, right? So first, you have to use this equation. Everything is given. Find the K value, and then substitute it in the T half equation. You'll get the T half. But there is, I think, one more shortcut of doing this. Anyways, you do this, I'll tell you. But I don't know whether it will work here. No, it won't work. There's no shortcut. I don't think it's that much of a calculation.
Sir, 3.75 seconds.
T half.
Yes, sir.
No. We'll see if anybody gives the correct answer. So initial concentration is 0.01, final concentration is 0.008. And yeah, guys, I want the answer in, okay, I'm sorry, like, I want the answer in minutes only. I don't want it in seconds. Did you, whoever gave me the answer, did you tell it in minutes, Kana?
No, sir, seconds.
So you're telling it's 3.75 seconds.
It's so, it would be so less, sir, in minutes then.
Exactly, correct, right.
So what's the K value, sir?
That's what you need to find, no? That's the point of this question. You
No,
have to
sir,
find the K value.
I found
Oh,
it,
you're
sir.
asking me what is the K value? No, I don't know. I have to calculate it. I have to see.
Okay.
Right? Anybody else?
Sir, is it 25 minutes?
Okay, there is a possibility. 1 second, I'll check. I think it should be the correct answer, but I'm not sure. Okay, so I have. Okay, I'll directly go for the formula. First, I have to find K and then substitute the K in the T half equation. So R naught minus R is equal to KT. R naught is 0.01 minus R is 0.008, which is equal to K, which I don't know, into 10 minutes. Like, I'm not converting into seconds because I want the answer in terms of minutes, but if this question is asked in your board exams, they will not ask you in minutes. So you have to convert this minutes into seconds, then only continue. Is that clear? Right? Okay, so for now, we don't have to do anything. We can keep minutes as minutes itself. Okay, so I can write K as, okay, if I 0 0.01, 0 0.008, 0 to, okay, that's it. Is it 0 0.00? No, this should be 9. So it should be 0 0.092 divided by 10. So it should be 0 0.0092. Was this the K value which you got? Right? Okay, now that's it. So I have a T half is equal to R naught by 2K. Right? So R naught is 0 0.01 divided by 2 into 0 0.0092. 0.92.
Sir, is it not 0.002, sir?
Yes, sir. Yes, sir. I'm getting
Oh,
2 into 10 to the
0.002.
power minus 4. 2 into 10 to the power minus 4.
What mistake I did? Okay, this will become 0. Okay, I'm sorry. Yes. I'm sorry. So it would be 0.002. That's it.
Yes, sir.
Okay. Yeah. Okay. Right. So now this has become an easy calculation. So 0.01, 0.004. Yeah, 25 minutes is the answer. Is your answer is correct enough? Right? So simple calculation.
First wrote it in seconds, so I got something really complicated.
Oh, you got something complicated. Okay, no problem. Right, so we'll move on. Okay, there is this interesting question. We will do this. Let me see if we can get the answer. So I'll just take this down. I'll give you a minute. Or if at all you want to, you don't want to complicate the equation and you want to get the answer in terms of seconds, do not do anything here. Right? Get the final answer, convert it into seconds. That's the easy way. I'm just telling about the calculation part to make it easier. Right? So if at all in exams, they just give this. You can do everything here, but again, put the units at each and every step because that's what is important. Like here, we're just doing the calculation. Right? So after getting the time value, then you can convert it to seconds. That is also a good idea. Okay, actually, this question we will not do. We'll actually go for first order reactions. Start. So it's just two formulas which you have to remember, guys, for your zeroth order reactions. Again, for first order, two equations. One for the first order and one for the T half. Right? Okay, so everybody I think is okay. We'll go to the next concept. Right, so we'll go for first order reactions. Right? Okay. So we know how the rate law is going to look for a first order reaction. R is equal to K into R power 1. 1 is the order, right? So again, I'll be able to write the rate of the reaction as change in concentration, rate of change of concentration of reactant, isn't it? So this R, I'll be able to write it as dr minus dr by dt. Again, why minus? We understand because reactant, the concentration will decrease. All that we already know is equal to K into R, right? So I'll bring dt this side, R this side, right? I'll bring dt this side, R this side. So I'll have minus dr by R is equal to K dt. Now I'll integrate on both sides, right? So again, same thing. It is from the initial concentration of R naught to the final concentration of R. And here it is from 0 time is t is equal to 0 to some time is equal to t, right? Okay. Now what is this integration gives you?
Log R.
Yeah, so integral dx by x is log x, right? Okay. It's actually not log, it's natural logarithm, it's ln, right? Hope you know the difference. If I write log to the base e, now this is actually ln. I'll write it like that, ln. If it is log to the base 10, then it is normal log, which what you use, right? What we get here will actually be log to the base e. Okay, so hope you know the difference between that. Like if at all you want to convert log to the base e to the log to the base 10, you will multiply by 2.303. Okay, hope you would have seen all that. Cool. So if we do this, so I will get log, I'll just write log, okay, I'll write as ln r minus of ln r, basically, right? Ln r from the initial concentration to the final concentration. Here I'll get kT. No problem. Okay. What's happening? Yeah. Okay. Cool. So now I'll substitute the limits. Generally, again, it will be upper limit minus lower limit. But since I have a negative sign, I'll go for lower limit minus upper limit, right? So the equation goes like this. Okay, so I'll have, and again, you can see that you will get it as ln r naught minus ln r is equal to kT, lower limit minus upper limit. That's it. Now you know how it looks. Log a minus log b will become log of a by b, right? So, and I'll convert this ln into natural logarithms also, right? I'll convert log to the base e to the log to the base 10. So what you have to do, if I have to do this, multiply by 2.303, right? So if I rewrite this equation, I'll be getting this like this. I'll get the final equation easily. So I have k is equal to 2.303 divided by t. I just got this t here, multiplied this by 2.303, and log a minus log b will become log of a by b. Log of r naught by r. This is the equation, right? K is equal to 2.303 by t is equal to, sorry, into log of initial concentration by final concentration. Done, right? This equation you have to remember. Definitely you are getting a 3 mark from this equation, right? Okay, so k is equal to 2.303 by t log of r naught by r. And what I want you to do is I want you to derive from this, I want you to derive what is the equation for t half. Can you do that? From this equation, derive the equation for t half. So you hope you remember what we did for t half for the zeroth order reaction. You know what will become to, what will happen to r, and t will become t half. So log 2 value is 0.3010. That also I'm telling you. Log 2 value is 0.3010.
Sir, could you repeat the value?
Oh, log 2, I'll write it here. Log 2 is 0.3010.
There is a 2.303 into 0.3010 by t half.
Sorry, I'm not able to get you.
2.303 into 0.3010.
That I know, right? Just calculate the answer and tell me.
Sir, it's 0.693 by K, sir.
Okay, that's the answer I was expecting, right? So yeah, your answer was correct enough. Whoever previously told me, but you just have to calculate and tell me, yes, the answer is correct,
Yes, sir.
right? Okay, so can I rub this part? Everybody took this down?
Yes, sir.
Okay.
Yes, sir.
Right, so it's simple now. So if I rewrite this equation, I write t here and k here, and I write it as t half, which is equal to 2.303 divided by k into log of r naught, and the final concentration will be half of the initial concentration. So that's it. So you'll get r naught, r naught getting cancelled, this 2 going up, so you'll have only log 2. So log 2 value I told you is 0.3010. So it is 2.303 into 0.3010. So this is the beautiful equation I'll get, a good equation to work with. So t half is 0.693 divided by k. So again, two equations, this and this. Okay, so let me trickle you into some graphs. Okay, say I have a graph between log of r and t. Okay, I have log r and t. Can you get this? Can you get this equation? Okay, no, you're not able to see. This is, wait, this is t. Okay, now you're able to see. So log r, that is log of final concentration, and t. I want, obviously, okay, I do it. You have to rewrite this equation a little bit. So it will be, or okay.
So straight line was
Yeah, it is a straight line.
It's slope as
Ask me the
complicated.
origin. Origin, how is it possible?
No, so intercept.
With an intercept. What is the intercept?
Intercept. 2.303 log of r naught by k.
Yeah, correct. That's the intercept. Good. Minus. Okay, so that's it. I got the equation. This is my t. So this is my y, and this log of r is my x. So this should be m, and this entire thing should be c. That's it. Right? So I just rewrote this equation. I wrote it as log of a by b, I wrote it as log a minus log b, and I just multiplied everything inside. Right? So I'll get 2.303 by k into log of r naught minus 2.303 by k into log of r. So this is my x, this is my m, this is my c. So you are going to have a negative slope. You can see there's a minus sign here, and obviously the graph is going to look like this, and this value is basically 2.303 by k into log of r naught. Correct? And the slope of this line is going to be what? You can see the slope is minus 2.303 by k. What will be the slope? Okay, right? So a simple graph. So yeah, other than this, graphs, I don't think you will have. And even if you have other graphs, it will be very easy. Okay, fine. Cool. So we'll go on to the problems. Problems are what is more important. Right. So we'll take down the question if you're ready. Right, your question. In a first order reaction, the concentration of the reactant decreases in a first order reaction. The concentration of the reactant decreases from 0.8 m to 0.4 m. Concentration of the reactant decreases from 0.8 m to 0.4 m in 15 minutes, 15 minutes. Right? Now the question is, find the time taken for the concentration to change from 0.1 m to 0.025 m. Find the time taken for the concentration to change from 0.1 m to 0.025 m. So I'll repeat the question as a whole. In a first order reaction, the concentration of the reactant decreases from 0.8 m to 0.4 m in 15 minutes, 15 minutes. Find the time taken for the concentration to change from 0.1 m to 0.025 m. Okay. Can you do it?
Sir, should we keep the
Minutes
time
or
in
seconds?
minutes or seconds, sir?
Sorry. So should we take the?
In minutes or seconds, sir, the time?
In minutes. I want the answer in terms of minutes.
Okay.
Don't have to change anything then. Yeah. So how will you approach the problem? They have given the initial concentration, final concentration, and the time period for the first case, right? So you have to find K from that, right? And use that K value to put it in the second case, that is from 0.1 to 0.025. But if you're smart, right? If you're smart, looking at the data, I can answer the question in 2 seconds itself. I don't even have to calculate it. Anything you see?
The T half, sir.
Wonderful. So what they're telling is basically the 0.8 to 0.4, 0.4 not the half the concentration of 0.8. So whatever the time period they gave you there is basically the T half. 15 minutes, which is given there, is the T half. But okay, with that, what will you do? So again, with that, we'll be able to find the K value. That is, you have this
K and
equation
then substitute, sir.
Okay. Still, that's little smart, but not that smart of how much I expect. The same thing, or can you work it out in the second case?
Then 2 times we need to do, sir.
Wonderful. Yes, that's the thing, right? Guys, look at this. This is pretty interesting. So if at all you're going to become engineers and all that, or I would say even if you're going to any field for that matter, these observation skills are very, 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 very important. Okay. Now look at this. So they're telling 0.8 to 0.4 is obviously is half. Initially 0.8, finally 0.4. So obviously t half is 15 minutes. Correct? Right. Now look at that. So when the initial concentration is 0.1 m, not 0.8, right? When the initial concentration is 0.1 m, say after 1 t half, what will happen to the concentration? So can I say it will become 0.05? Correct. Now if I go for one more t half, what will happen? 0.05 will become 0.025, right? So how many t halves? So how much times? It's basically 2 times t half. It takes for the concentration to become 0.1 to 0.025. So the answer is 30 minutes. That's it. So you'll find K, substitute in that equation, get the answer. So if at all I've given this question 1 mark, this is how you need to answer, right? But if the same question comes in 3 marks or 4 marks, then you have to show that you're not smart in the paper at least, right? So that you will get marks. But that's how a system is. A system are. So the thing is, this is the best way to do the problem, right? So from 0.8 to 0.4, they have given that this thing time period, and they didn't tell it directly, but still we can understand that this t half, right? And from 0.1 to 0.025, 0.1 to 0.05, 1 t half, 0.5 means 0.05 to 0.025, next t half, so 2 t halves, answer is 30 minutes. Everybody understood? Guys, please give me a yes.
Yes, sir.
Yes, sir.
Right? Cool. Okay. Next question. What is the time? Do we have time? Yeah, we have time. Yes. One more question. Right. The half-life period of a first order reaction, the half-life period of a first order reaction is 6.93 minutes. The half-life of a first order reaction is 6.93 minutes. Right? Now the question is, find the time required. Find the time required for the reaction. Find the time required for the reaction to get 99% completed. Find the time taken for time required or time taken for the reaction for getting 99% completed.
Sir, T half is
T half is 6.93 minutes. The half-life period of the first order reaction is 6.93 minutes, and they're asking you the time taken for the reaction to time taken for the reaction for 99% completion. Right. Now before you start substituting the formulas, what is the connection between R naught and R here? Tell me, what is the connection between R naught and R? In this question, obviously, not like generally I'm asking, in this question. So what I'm asking is, you have the equation for first order, that is K is equal to 2.303 by T into log of R naught divided by R. What will you substitute for R naught and R? That's what I'm asking.
sir, yes, R is equal to 99% of R naught.
99% of R naught. Okay, that's not how you like. It's not exactly like that. Please understand. Okay, say initially I had 1 m. You can actually substitute any value. Okay, I'm just giving you an example. Initially I had 1m. Okay, so in that 99% of this 1m got over. That means what? 99% of the initial concentration is over. So what will be remaining? Can I say only 0.01 will be remaining? Or let me put it like this, right? Say I had 100m. 100m was the initial concentration. Okay, so 99% over. So what is remaining? That is what is our final concentration. So what should be the final concentration in this case?
1m.
1.
1m, right? Very simple, right? So now, please guys, you can actually always remember this. So if they give you percentage completion in the question, if they give you percentage completion in the question, so I will be able to say that is some x percentage. I'll write it as some x percentage. What about the percentage? Okay, so now how will I be able to write this is r naught initially I have. So it's percentage completed, right? X percentage completed. So I'll be able to write this as 1 minus, or I will write it as 1 minus x by 100 into r naught. That's what is going to happen. Why I put 1 minus? It's because I'm just converting the scales in terms of 1. Percentage is between 0 to 100, right? So I divided by 100. So I'm converting the scale between 0 to 100. Or if at all you don't want to remember this, you can just go by the logic, right? So how will I go by logic? Say now it's log of r naught. So I say 99% is completed. So only 1% is remaining, right? So 1%, how will I write? 1 divided by 100 into r naught is what is remaining. Is it not? Right? 1% of r naught is what is remaining, right? So obviously I can write it as 1 by 100 into r naught. Okay, right? Or I can even write this equation like this: log of r naught divided by r naught minus x. If I can even write like this, but this x is nothing but percentage completion divided by 100. Anyway, you can write. However you want, you can write. I prefer going by logic. Like I don't have to remember any formula. Actually, that's at least my thing. Like more and more formulas you remember, more and more it is difficult. Sometimes you might forget. But if you remember the logic, right? So definitely you're not going to forget that, right? So initially I had 100%. They say 99% is completed. So I can write it as 1 by 100. 1% of r naught is what is remaining. So 1 by 100 into r naught. Or I can write this equation as r naught by r naught minus x, where x is the percentage completion divided by 100. That will also. So this is what is my final concentration now. How much completed? How much initially I had? So that is what is the remaining part. So either way, any one way, you will be able to write this. Or the best, easiest way is to assume some value for r naught, and the ideal value for r naught you assume is 100 if they give you percentage, because it's easy, right? If I whatever the initial concentration is, right, that some percentage is completed. That's what, right? So in this case, I consider it as 100m, right? So now what will be remaining? Only 1% is remaining, so r is 1, right? Say if they tell that 60% is completed, right? Say 100m I have, so 60% completed. What is remaining only is 40%. So it will be what? 40% of r. That is 4 by 100 into r. I mean r naught. Sorry. Right. So either way, it is going to this thing. What is going to be okay? So if I can say that 60%, right? So 100, and this will become 40. Because 40% is remaining. See, this r is the final concentration remaining, right? It's not percentage completed. Okay, so then we can do the problem. I want the answer in terms of minutes only, so I don't have to convert anything. Yes, any answers? Sorry?
26.06 minutes something.
26 or 46?
46, sir.
460 after doing something.
460, okay,
Yeah.
fine. We'll see which is correct. Okay. So the equation is, so first they have given T half. T half is 0.693 minutes. So first I'll find my K value. K value will be 0.693 divided by, oh, it's what they gave you 6.93 minutes. So, okay, sorry. So K is equal to 0.693 divided by T half will become 6.93. So this will become basically 0.1. Is it correct? Yeah, 0.1.
Yes, sir.
Okay. So now I'll go to the equation. So I have K, that is 0.1 is equal to 2.303 divided by T. That's what I asked him. Time taken for 99% completion is equal to log of, say if I keep it as 100, the initial concentration, the final concentration 99% over. So finally I have only 1. So 100, log of 100. So log of 100, how can I write? This is basically log of 10 to the power 2, right? So if you have A power B, so so I can write like this: T is equal to divided by T is equal to 2.303 divided by 0.1 into 2 into log of 10. I just log of A power B, I write it as B log A, right? So now log 10 value is 1, right? So log 10 value is 1. So now 2.303 divided by 0.1, it is 10 power minus 1. So 10 power minus 1 goes here. So it will be 23.03 into 2. So the answer is yes, 46.06 minutes is the answer.
I got it until the last step, sir. I must have done some mistake.
Yeah. No problem. So 46.06 is the answer. Simple, right? So you have to, like, they will just test you with the percentage values only. So if you can bring this R naught and R correct, your entire problem will be correct. No, and obviously you have to be good at calculations, right? So if you can do that, very easily 3 marks, just like that you'll get, and definitely you'll get this question, this kind of question. So you will definitely get that tabular column question and this kind of question for sure in your board exams. Okay, fine. That's it, guys, today. So we'll do some more, like 1 or 2 problems more in first order, right? Then we'll see how rate depends on temperature, right? So we know obviously all the things which you have seen till now are at some constant temperature, right? So if temperature is changing, right, so what will happen to the rate? We'll get a mathematical relationship and we'll see how exactly chemical reaction occurs, the mechanisms of chemical reactions, right? There's something called as collision theory, right? So all these things we'll see next class. Okay, fine then. Thank you, guys. Bye bye.
Thank you, sir.
Sir.
Thank you, sir.